Well, good evening, everyone. It's 7 o'clock. We're not going to get started quite yet, but really happy to be here with you, myself and my colleague, Richard Gutierrez. She started in mid-May, about a week after our last spring basic spotter talk. She comes to us with a lot of energy, loves outreach and teaching people about the weather. So it should be an action-packed night tonight. Just a couple logistical things before we get started. Please make sure you're muting yourself. We do have control to mute everyone. But if you could just do us a favor and mute yourself so we don't have the background noise. We'll talk about some of the logistics as far as interaction. But in the meantime, if you're interested in following along with the slides, I just uploaded about 10 minutes ago a PDF. So if you go to your handout section on the side there, you're going to be able to see several handouts. Those are all things you're going to get some use out of. But in particular, I think it's like SKYWARN October 2020. If you basic SKYWARN Talk October 2020, if you download that, you're going to be able to follow along with the slides. So if that's of interest to you, please do that. Otherwise, just go ahead and sit tight. If anybody could please chat and just let us know that you can hear us and see us okay, to make sure the technical difficulties are all squared away. And we'll let some more folks filter in here and get started in a minute or two. Thanks so much for joining us. Rachel, I can't see the chats. Are they hearing us and seeing us okay?
Nothing has come through the chat yet.
Gotcha. Okay. I'm assuming we're doing okay. Are there any questions that have come through or anything?
Loud and clear in Pittsburgh, someone says.
Love that. Sweet. Sounds good. Again, we'll just wait a couple more minutes to let some more people filter in here, but you're at the right place. Basic Spotter Training 2020, National Weather Service State College. And I'm going to just be finishing up a little dinner here, so don't mind me chomping on some food. But then we'll get started here probably around 7:05 or so.
There are some questions about the handouts. Those are just resources for you to use, so you can pick and choose. You can choose all of them, look at them. You can choose none of them. It's just for your own reference. And one of the handouts is a copy of the slides we're going to go through today, and that's the Basic SKYWARN Talk October 2020. So if you want to like print those off and write on them as we go through it, that's totally fine. And the rest of it's just for your reference.
And folks, yeah, the repeaters is a list of the repeaters for our amateur radio operators. The Spotters Field Guide is kind of an expanded version of what we're going to give tonight. It's got all kinds of details. It's kind of like the the spotter handbook, if you will. And then the spotter reporting guidelines is going to be important at the end. That's how that's how you can communicate with us. So that's got our phone number, our contact information, and some details about how to be a spotter. So all that stuff can be useful for you. We'll talk about many of those through the course of the training tonight. And now that it's 7:05, let's go ahead and get started. Rachel, anything else urgent in the questions that we need to address before we get rolling?
Nope, everyone can hear us and we're good to go.
Okay, sounds good. Well, welcome everybody. My name is John Banghoff, meteorologist at the National Weather Service and State College. I am here with my colleague Rachel Gutierrez, who is a action-packed and excited individual tonight to do her first basic spotter training. Rachel joined us in mid-May and was instrumental in the advanced spotter talk for those of you that are able to attend that. And we're really excited about a revamped and kind of modernized spotter training. Gave the presentation some love and excited to be here with you tonight. So we expect this presentation to probably be about an hour and a half to 2 hours. This is actually the first time we've done this basic talk. So that gives you a ballpark. There will be some breaks to get up and stretch. We know many of you are probably working from home in the midst of the pandemic, and so sitting in front of a computer maybe isn't as fun, but it does help us reach a whole bunch of people. So we're glad you're here tonight. If you have any questions, please let us know. We're going to, let me see if I can click through. Yep. I am actually controlling the PowerPoint on Rachel's screen, FYI. So as we work out the technical difficulties, just bear with us. But as far as engaging with us, please ask us a question. You can enter your question in the GoToWebinar window on your screen. You should see that in the GoToWebinar menu, or you can raise your hand at the end. We will pause to take some questions occasionally, probably at the end of each section before breaks. But at the end, we'd be more than happy to address any questions you may have. As we get started tonight, I want to talk about just a few things here. Let's see, my mouse is not being terribly responsive. All right, so who we are. We're at the National Weather Service in central Pennsylvania, located in State College, and we're made up of a group of 14 forecasters, 6 electronics technicians, 1 IT support person, a hydrologist that works for our office at the weather forecast office side, a science and operations officer, with an observations program leader, a warning coordination meteorologist, an administrative assistant, and a meteorologist in charge. And so it's a big group of people. We're open 24/7, 365, and our main role is providing warnings and forecasts for the protection of life and property across central Pennsylvania. In the midst of the pandemic, we've been largely unaffected. We're still having people at the office 24/7 because you can't issue a tornado warning or severe thunderstorm warning from home. We have had some telework capabilities built in, but largely our operation has been unaffected by anything with COVID, and we're thankful for that. We've continued to stay healthy, and we hope the same for you and yours across Pennsylvania. So as far as interacting with us online, just wanted to throw this up here first: Facebook, Twitter, YouTube, and our website, weather.gov/CTP. And you can see a map here of the different weather service offices. We'll talk about that here in just a little bit. As far as our organization, we're just going to go some of the bureaucracy or some of the organizational structure of our agency so you can become more familiar with it. Our parent agency is the National Oceanic and Atmospheric Administration, which falls under the Department of Commerce. We are a federal government agency, so we are, Rachel and I are federal government employees, and our primary mission, as I alluded to earlier, is the protection of life and property through the issuance of forecasts and warnings. So our jobs literally are the protection of life and property that motivates us. That's our mission statement, and it's something we're very passionate about. As far as the National Weather Service is concerned, some of you may be familiar to varying degrees with the various national centers that we have. There are 9 national centers: the Aviation Weather Center, Climate Prediction Center, et cetera, et cetera. You're probably familiar with the National Hurricane Center, especially this fall, because it's been super active. The Storm Prediction Center as well is probably one that you may be familiar with, and then the Weather Prediction Center. And then on the local level, there are 122 local weather forecast offices, one of which is ours in State College. We have 5 offices that serve the Pennsylvania area. And then there are 13 river forecast centers. They're responsible for our river forecasts, river flood warnings, things like the Susquehanna River, the Juniata River, et cetera, et cetera. There's also 6 regional offices: Eastern, Central, Southern, Western, Alaska, and Pacific. And then our National Weather Service headquarters is located in Silver Spring, Maryland. So that gives you an idea of kind of the structure of our organization. And now let's look at where the offices are. So there are, again, 122 offices across the country. Also offices up in Alaska and Puerto Rico, and then Hawaii and Guam. We are here in central Pennsylvania. Many of you are probably familiar with that. If you are not in the central Pennsylvania weather forecast neck of the woods, that's totally fine. We'll talk more about those details later, but this training should be transferable to any office in the country. Here is our office in Innovation Park, and we have arguably one of the best views of any National Weather Service office in the country, overlooking Mount Nittany. This is obviously not a fall picture. The trees have started changing color, and man, it's beautiful outside our office. Now, as far as the offices serving Pennsylvania, as I mentioned, there are 5. The first one is Cleveland, Ohio. You can see here just 2 counties in far northwestern Pennsylvania. Then as we move farther east, we have Binghamton, New York, which covers part of northeastern Pennsylvania. Then in the southeast, we have the Philadelphia Mount Holly office, and they're actually located in New Jersey. And then the Pittsburgh office out to our west, great neighbors and friends there in Pittsburgh. And then finally, our office here located in southern Centre County. And you can see the county warning area boundaries. Our CWA extends from Warren in the northwest all the way down to Lancaster in the southeast. Widely variable weather and a whole lot of different things to worry about. So things are often busy, and we like to stay busy with a wide variety of weather going on in central Pennsylvania. We're going to talk about some of those things tonight. And again, State College, my favorite weather forecast office, maybe not yours, maybe it is yours, who knows, but we're a little bit biased, certainly. Now, as far as local office, I alluded to this earlier, 26 people working there, and we have some specialists open 24/7, 365. And here's just a view of what our workstations look like. So on the left here, you can see there are 2 PC screens, so we're able to access the internet. We're able to look at weather forecast information and communicate with partners. That looks like emergency managers, departments of transportation, etc. And then we have over here 4 computer screens that make up our what's called an AWIPS workstation. So that's where we're actually making our forecast. That's where we're viewing some of the forecast data that comes in, satellite, radar, etc. That's where we're issuing warnings. And so many screens at our offices, but it certainly helps with the operation we have. We have, I believe, 8 different workstations that look just like this at our office for varying staffing. So how do we typically work on a given day? So a day like today where it's relatively quiet, plenty of sunshine, not much going on around the Commonwealth, we have basically 3 different shifts. First is the short term. That's going to cover the 0 to 24 hour, maybe even the 36-hour forecast. And that's often going to be staffed by our lead forecaster. He's going to be the one, he or she's going to be the one making warning decisions, doing aviation forecasting, and also handling things like staffing. Do we need more people for hazardous weather? They're kind of the shift lead. Then you have the long-term desk. That's the shift that I worked yesterday, actually. That's looking at days 2 through 7. Our forecasts go out through day 7, and we're looking at longer-term models. We're often also assisting with some of the decision support duties, so sending out briefings to partners. As we head into the weekend, we're going to monitoring the remnants from Hurricane Delta, and we may need to issue a briefing if there is a flooding concern across Pennsylvania. We'll have to see about that. But the long-term desk is focusing more on the long range. And then finally, the public service desk. That's the desk that Rachel has been spending quite a bit of time working on as she has gotten spun up. That's answering phones, doing quality control of products, monitoring and making sure to know whether radio is working properly, and also handling things like social media, basically a public-facing desk. And so that's a typical day in the life. But what happens when the weather ramps up a little bit more? So you have your storm coordinator. That's the person that's kind of overhead. And then we'll bring in additional staffing. As I mentioned, we have room for as many people as necessary. Sometimes we can even have 8 people in the office for big severe weather outbreaks. You're going to have a short-term forecaster, long-term forecaster, and public service, as we talked about. But then you might have somebody dedicated just to social media, or you're a decision support meteorologist. And then finally, your radar and warning team, which is really, really important as we start getting into big severe weather events where there's multiple storms across the county warning area, multiple warnings being issued at one particular time. And so we can certainly ramp up from the 3 people that we have during the day. Overnight, we also have 2 people, obviously, unless there is more significant weather, that warrants an expanded staffing. So the key piece of equipment, my apologies, you may have seen this before. This thing on the left is a Doppler radar. Sometimes I refer to it as a golf ball up on a tee. This is located up in Black Moshannon State Park. It basically sends out electromagnetic waves, reflects back if it hits anything, and it can pick up precipitation. So that tells us how much is out there, which direction it's moving. And now with dual polarization radar, come to our advanced talk to be able to learn more about that. Radar can even give us an idea of what is out there, if it's snow, if it's bugs, if it's rain, whatever it might be. We also use satellites. The GO-16 satellite has been instrumental and being able to observe what's happening in the atmosphere. We really like that. Plenty of computers because we have to bring data into our office and also send it back out. So definitely a lot of computer stuff. And then finally, remote sensing equipment. We have an ASOS, an automated surface observing system at every single, well, many of the airports across our county warning area, and then a variety of observing sites, whether that's a citizen weather observer, somebody that's got their own weather station, or whether that's through Pennsylvania Department of Transportation on the roads. There's all sorts of sensors that we're looking at to keep an eye on the current weather to make sure that our forecast is good, and in the future we can make a better forecast based on knowing what we do right now. So now let's talk a little bit about the SKYWARN program. Just want to kind of buzz through this so we can get to the good stuff. But the SKYWARN program is a group of trained volunteers. That's what you guys are. You're volunteers because you're volunteering your time. We're not paying you. Unfortunately, we can't do that, but we appreciate that you're volunteering. And tonight, the plan is to train you so you can report hazardous weather in order to, one, we want to supplement remote sensing equipment. We can't have a piece of equipment every single place around Pennsylvania. So we need your eyes on the ground to be able to supplement that remote sensing equipment. We want real-time ground truth. For example, our radar might be indicating that it's raining hard at a particular location, but if it's not, we want to know that. Our radar may not be picking up on the fact that the winds are maybe 50 miles an hour. We want to know that. So you're providing us the ground truth to make sure that we have an accurate representation of what's happening on the ground at your location so that we can communicate concise and timely information to people in Pennsylvania to keep them safe. And finally, your reports are going to help us add credibility to our products and services. For example, if we issue a tornado warning may say radar indicated rotation. Okay, that's fine. But if we can say something like a train spotter has reported a tornado at the intersection of XYZ, that's going to bring a whole lot more validation to the fact that we're issuing a tornado warning, is going to encourage people, we hope, to respond accordingly. So if you provide us information, that's going to be really helpful for us. And we really appreciate the time you're taking tonight to be able to give information to us so that it can help us issue better warnings and serve the people of Pennsylvania more effectively. And literally, SKYWARN spotters act as thousands of eyes and ears out in the field, supporting our forecast and warning program. So we appreciate you being here. We're excited about this tonight, and we hope that you'll learn something as we go through this evening. National Weather Service State College has over 3,000 trained spotters. We actually have closer to 5,000 on the books at this point. Certainly some of those have maybe moved away. Some have unfortunately probably passed away, but we still have over 3,000 trained spotters, and we want to continue to build that database. Statewide, there's about 10,000 spotters, and nationally, there's about 300,000 trained spotters, and I would guess this number continues to grow every single week. Now, one thing to note is, though you're training today in State College, if you ever move or if you live in a different location, just reach out to your local office wherever you go, because that's the information you're going to need. If you're out in Wyoming and you call us, we're not going to be able to do much with that. We can relay that information, but it'd be better if you directly contact your office. Again, we'll talk about that here in just a little bit. So today we're going to cover the basic aspects of observing weather and emphasize the accurate reporting of those observations. So we're going to review some key definitions, look at some different weather elements, and we want to make sure that we're giving you some guidance on what information is helpful for us and what to look for to be able to provide us accurate and actionable information. And once complete, you're going to be a certified SKYWARN member, part of the National SKYWARN team. So that will be a fun development. All right, hanging in so far. Thank you guys so much for listening. If you do have questions or anything, please continue to enter them in the chat as they come up. But we're now going to transition into kind of our forecast process. We talked about the staffing. Now we're going to start looking at the ways that we communicate with the public leading up to an event. This is to help your situational awareness. So if you're interested in spotting and communicating with us, you can be weather aware to know what's coming. And sometimes we can even know something's going to be happening 3, 4, 5, 6, 7 days in advance. So it's a 3-tier approach. On the y-axis is the time to the event. Okay. On the x-axis is the confidence in the forecast. So starting far out from the event, so high up here on the y-axis and low on the x-axis is going to be our outlook phase. This is going to be probably 3, 4, 5, 6, 7 days out. We're not very confident yet on the details, but we're just kind of giving some basic ideas. Hey, this could be something to keep an eye on. As we move closer to the forecast, or closer to the event, I should say, then we enter the watch phase. And then finally, we enter the warning phase as the event is much closer, our confidence has increased. So a 3-tier approach is what we adopt here at the National Weather Service. Now, as we move to the next slide here, we're going to talk about an outlook versus a watch versus a warning, and there's going to be some opportunity for a little bit of trivia. So outlook, it is a possible weather event in the future. A little bit lower confidence. Now I'm going to come back to this. So think about what percentage chance of occurrence this might be with the outlook. If you've attended this course before, please don't ruin it for everybody. But the lead time can range from about 3 to 7 days, and there's no details either in timing or severity, just a heads up. We might be saying like, hey, severe weather is possible, today's Thursday, severe weather is possible Sunday and a Monday. We could be saying, watch for a snowstorm early next week. Things like that, just to get your eyes in your mind zoned into that. So as far as the percent chance of occurrence, what are we talking about with an outlook? We don't have a great way to interact here, I'm thinking, but go ahead and think of a number. And I'm going to go ahead and we'll do a drum roll, please. And 30 to 49% chance of occurrence. So we're still not more confident it's going to happen than it's not going to happen, but it's at least a possibility. So 30 to 49%. Now watch. Then we're increasing in confidence a little bit. Conditions are favorable for a given weather event. It's not happening, it's not ongoing, but it is at least favorable. Severe thunderstorm watch, winter storm watch, etc. In fact, the chances of occurrence for this, what do you think they are? Think about something. The lead time for these watches is going to range in time from a few hours in the case of a severe thunderstorm watch to several days in the case of a winter storm watch. So in winter, we generally have a little bit more lead time. Severe weather, not as easy to predict, so it's going to be a little bit shorter. And here's the thing to note as well. Some watches are going to lead to bad weather. Some won't. That's the nature of a watch. There's always some uncertainty. So if 30 to 49% was the outlook, what do we think the watch was? The confidence, 50 to 79%. So now we're starting to tip the scales in favor of the event happening. Still not a certainty, but at least getting a little bit closer. And then by deduction, I think we can probably all figure out what the warning confidence is going to be. In the case of a warning, conditions are imminent or extremely likely for a given weather event. So not necessarily 100% certainty, but we're getting there based on our outlook being 30 to 49%, our watch being 50 to 79%. If we continue the pattern, we're probably thinking it's going to be what? Greater than 80%. Makes quite a bit of sense. Now with warnings, lead time can range from a few minutes in the case of a severe thunderstorm warning or tornado warning to about a day. Sometimes we might issue a flood warning for a river, or a winter storm warning when we know that snow is going to be starting, snow or ice is going to be starting within the next 12 to 24 hours. We might put out a winter storm warning. So you can see, depending on the time of year, these things vary, but this gives you the overview. Outlook, watch, and warning. Encourage you to pay attention to those so you can be a better spotter, knowing what's coming and able to communicate information to us along the way. Now, as far as the outlook, let's talk about some specifics of what that might look like. We're going to focus on the warm season right now. Hopefully, at some point, we'll be able to talk more about winter, but that'll have to be in a future class. So the first thing with the outlook is the hazardous weather outlook. We issue this daily. If there's any significant weather in the forecast, likely if you go to our website, www.weather.gov/CTP, you're going to be able to see our hazardous weather outlook, and that's going to give you an idea of, hey, we're expecting some sort of hazardous weather in the next couple of days. For severe weather, the Storm Prediction Center, if you go to spc.noaa.gov, you're going to be able to access these severe weather outlooks that go out to 8 days. And they're going to be able to give you an idea of, okay, where are we expecting significant weather? In particular, for SPC, this is a day where we had an enhanced risk earlier this year. And you can see this is going to give you kind of an idea of risk categories. In this case, we were an enhanced risk across much of Pennsylvania, which means numerous severe storms are possible. We're not talking about necessarily the amount of intensity. We're not necessarily talking about the timing, but we're just saying, hey, keep an eye out for this. And those are going to be our outlook phase. Then we transition to our watch phase. So this is where the Storm Prediction Center, again, in collaboration with the local forecast office, is going to highlight an area where thunderstorm development is likely over the next couple of hours or say through the afternoon. And so they might draw something like this here on the right, which is a polygon highlighting, okay, maybe there's going to be some storms. This, in fact, was the derecho that went through southeast Pennsylvania through New Jersey back in June. Some of you may remember that. And so the Storm Prediction Center highlighted this area as being ripe for severe weather activity. And you can see Watch County notification for Watch 242. National Weather Service has issued severe thunderstorm watch 242 in effect until 3 p.m. this afternoon for the following areas in Pennsylvania. And so again, that is the watch phase. Heads up, keep an eye out. And then finally, we transition into the warning phase. This is when conditions are imminent, right? So in this particular case, we issued a severe thunderstorm warning for parts of Center County, down on over to counties to our east. You had eastern central Center County, Union County and southeastern Clinton County. A severe thunderstorm warning issued for 60-mile-an-hour wind gusts and quarter-size hail. In this case, radar indicated. Now, if you had reported to us that you were getting hail, we could say spotter reported, right? So that's going to add some credibility to our warning. But again, this is the idea, outlook to watch to warning. This is similar for winter, maybe just a little more spread out in time. Maybe the outlook's going to be day 3 or 4. The watch might be issued on day 2, and then the warning may be issued a day before as opposed to, the day of. Okay, you guys have hung tough. Let's go ahead and take a quick break. If you need to go get some water or something. It's been about half an hour, not a whole lot of time, but let's go ahead and take a break. And if you have any questions about how this stuff's working, this will also give you a chance to download the PDF if you want to follow along with the slides. Please download those handouts and take a look at them. And then we'll be back here in 5 minutes. We'll start at 7:30 sharp. Rachel will be talking about winter weather at 7:30. So we'll see you back here in just a few minutes. Thanks so much.
All right, 7:30 on the dot. Hopefully all can hear me and see the screen. So we're gonna get started with winter weather. Hopefully you've had time to stretch, use the bathroom, get some water, whatever you need, or snacks. All right, so if you were with us with the basic SKYWARN talk back in May, obviously we had a focus on severe weather because we were approaching the severe weather season, and we wanted to make sure that you all had everything you needed to be able to report on severe weather. But now we're entering into winter weather. It's almost Halloween, temperatures are getting chillier, the fall colors are coming out, so now we need to get prepared for how to report on winter weather and what that looks like. So let's get started here with snow measurements. First of all, snow measurements are not an exact science. There's a difference between telling us a snow rate and then a snow accumulation. Those are very different things, and they're both important. We both want to know, we want to know about both of those things, but there are differences between them. So snowfall rates are short-term accumulation amounts. So for example, it's snowing at a rate of 1 inch per hour. And a snowfall accumulation is how much snow is falling from a storm. So the storm is long gone and we got a foot of snow from that storm. That's the accumulation. When the snow is falling and we can see it's big, fat, juicy flakes that are coming down, and there's a lot of them coming at the same time, and it's really, really heavy snow, we might say it's 1 inch an hour or 10 inches an hour, which is not something that's realistic, but you get the idea. So in order to do snow measurement, you need some equipment, and fortunately these things are not hard to come by and they're pretty inexpensive. So the first thing is a snowboard, which is about a 2 foot by 2 foot board, preferably painted white. Now, being painted white is actually really important because if it's painted a different color, like black, for instance, that's going to melt the snow when it hits it, because black has a low albedo and it's going to absorb sunlight and then warm up the board. So we'd like the board to be painted white. Now you might be thinking, but if it's painted white, I can't see the snow. And that's why at the bottom here we have the orange flags that help mark your snowboard. So first, find a snowboard that's painted white. That'll help preserve the snow. It won't melt when it hits it. Get a ruler that's preferably divided into tenths so that you can get exact measurements when you're measuring your snow. And then get some flags so that you can mark your white snowboard when the snow's falling. It's easier to find. So this will be really helpful. And if you have other things like sticks, that'll make it easier for you to find if the snow is really, really deep. That'll also be extremely helpful. So here's the official method for snow measurement. Step number 1 is to find a location that's representative before the storm. So this means not near a building, which may affect snow or drifting, not near any trees or bushes, which may shelter the board. You may notice that if you're near a building, there might be crazy snow drifts that are 8 feet tall, but then everywhere else in like a parking lot, the snow is only 1 foot, and that's because of the effect of the wind around a building. And if you're near trees or bushes, you might notice that the snow underneath the tree is minimal. It's like just a dusting versus being out in the middle of the yard, it's 3 feet of snow. So that's why we want to keep our board away from those objects so that we get an accurate measurement of what's actually falling. And if you're a hardcore snow enthusiast, you may actually have multiple locations of your snowboards to take measurements, which is really helpful for knowing variations between your yard and knowing which are the greatest spots to put your snowboard. So if you really want to do this, go for it. Step number 2 is to place your snowboard and your flags so that you find it when it's snowing. And don't measure in the grass. Your ruler will be pressed to the board and it will inflate the measurements. So use a white snowboard to lessen the melting, as we discussed before, and then make sure that you're not like pushing your ruler too far into the snow. You want to just gently place it onto your snowboard so that you can get the most accurate measurement. Step number 3 is to then finally measure the snow. So get that ruler out, and we want to measure the snow once every 6 hours. Now this is very important to do it once every 6 hours. More frequent measurements will not allow for snow settling and will inflate the actual measurement and make it larger than it actually is. Less frequent measurements will allow for too much settling. So it'll deflate our measurement and it'll be too small for what actually is happening. So 6 hours is the standard agreed upon interval that we need to be measuring our snow. And after you take your measurement, wipe the board clean and get it ready for your next 6-hour interval. So repeat all these steps until the storm is done. Now, if your storm ends before your scheduled 6-hourly reading, just measure the snow when the snow stops. Don't wait the full 6 hours because that might change what is actually happening with the snow measurement. So add your 6 hourly measurements together when the snow is done and the storm is over, and that is going to be your storm total snowfall. All right, but what about snow depth, which is a completely different thing, remember. Snow depth is it's not snow that is the sum of your 6 hourly measurements. It's the snow that sometimes it's less than your snow rate or what you measured with your 6 hourly measurements. So again, you want to measure on a flat, hard surface, no measurements in your lawn, and then consider wiping away portions of your snowboard every 6 hours again. And the undisturbed portion could be used as your snow depth. So again, this is not the same as your 6 hourly measurements. Okay, so now we're just gonna watch a really fun video. There's Gumby in the background and snow is falling, and this person put a ruler standing straight up so they can watch as the webcam continues how much snow they actually got in their backyard. So we'll just play that again because it's really fun to watch. All right, moving on to sleet and freezing rain. Sleet and freezing rain are not the same thing. Sometimes they are confused to be the same thing, but they're actually very different objects. So sleet are little balls of ice that bounce when they hit the ground, and you treat this similar to snow. It accumulates, you can shovel it. If it's sleeting while you're driving, it's much less dangerous than if it's freezing rain and you're driving. So sleet can accumulate, and if you're getting a lot of sleet, measure it, and you can tell us what the measurement is. Freezing rain, on the other hand, is liquid raindrops that freeze on contact when they reach something that's cooler than 32 degrees Fahrenheit or 0 degrees Celsius. So it's raining, and then every drop of rain freezes instantly when it hits something. This can be extremely dangerous. As we can see, this is a tree branch that's been coated in a glaze of ice. This can be extremely dangerous for driving, and you want to measure an accumulation of ice, which is generally in 1/10 of an inch. And when you do this, make sure that you try to be as accurate as possible. If you're measuring ice around a tree branch, as in the photo, divide it by 2, because we don't want both sides of the tree branch. We just want what's on the top or on the bottom, because those will be different. And we're going to move on now to finally ice jams and river flooding. So we don't get tons of ice jams here in PA, but they are possible. And in the spring, river ice can break up because it's starting to melt, it's getting warmer, and then it can get stuck in the river. And when that happens, we get an ice jam, and then that leads to flooding. There was a pretty bad ice jam flooding incident that happened in Colorado a few years ago. So this is something that you definitely want to be aware of and report if you see this happening, and if the flooding is getting really bad, we definitely want to know about that. All right, so now we're going to move on to severe summertime weather. So we're going to backtrack a little bit, because even though we are starting to enter the cool season, we still might get a few more thunderstorms in between here and the winter weather storms. So we're just going to review a little bit of this. So severe thunderstorms, what makes a thunderstorm severe is that we have one of 3 conditions. We either have winds greater than or equal to 58 miles per hour or 50 knots, or we have hail greater than or equal to 1 inch in maximum dimension, or we have a tornado occurring. So You only need one of these three ingredients to make a thunderstorm severe, but you also need to be conscious of other threats like lightning or flooding that can be detrimental and hazardous to you and your safety. So what about sub-severe storms? What about those storms that just don't quite make the cut? Those we issue special weather statements for, and they obviously will have some impacts. They might be borderline severe, but they're not quite severe yet. So that's about winds between 30 and 54 miles per hour, and about pea to nickel size hail. So things that you need to be aware of and thinking about and protecting yourself from, but it's not quite severe yet. So the thing about these sub-severe storms, they do not set off tone alerts, emergency alert systems, and they rarely trigger phone apps. That's the one thing you need to know about these is if you have radar apps that you're paying for, if you're frequently checking the website, you may see that we've issued a special weather statement for your location for a particular storm, but it's not something that's going to be thrown in your face like a thunderstorm warning or tornado warning. So be aware of this, but it's not going to be something that goes directly to your phone. So in other winter situations, conditions might not meet winter storm warning criteria, but it could meet an advisory, which is similar to the special weather statement except for winter storms. So what you want to do here is don't think of an advisory as a less likely occurrence than a warning. Just think of it as an event with lower impacts. There's still an event happening. It's still going to provide impacts of some sort. It's just not quite as severe or intense as severe thunderstorms or winter storm warnings. All right, so now we're going to watch a video here quickly about severe thunderstorms. We can see the wind and the rain is picking up. Hopefully this is coming through. All right, now we see tree branches starting to fall. Wind obviously is picking up. There's lightning, heavy rain. Tree branches are coming down. Storm's getting more intense. We can see the wind just from how the rain is moving across the street. All right, big gust of wind here. Now, I would advise that if you are in this situation that you're not sitting right by the window with your camera, because you never know what debris might come into your house. If it is a severe thunderstorm, definitely debris could break the glass and come into your house. So definitely want to practice safety in these events. We're not asking SKYWARN spotters to risk their lives or anything and put themselves in danger. We want to make sure that you're all still practicing safety, but that you're also giving us reports. So make sure that you're practicing everything you can to be safe in situations. All right, so we got the gist of this. So this storm's pretty much wrapping up here, but there was some severe damage to trees. We saw wind gusts, we saw this heavy rain, but the most important thing is that we see damage. Wind gusts, if they're above 58 miles per hour, definitely we want to note that. But if we see damage, that's important to report to us and note as well. Okie doke. So now we're going to move on to river flooding. A little bit shift from the severe weather, but still really important. And the forecasts come from our River Forecast Center, which also happens to be located with our office here in State College. And these are for specific gauged locations along mainstream rivers and large tributaries, and the locations where it takes more than 6 hours for the waterway to respond to heavy rainfall. So many streams and creeks are ungauged and are covered by the flood and flash flood products. So river forecasts are driven by the time of year, what's the foliage like, what's going on upstream, and then if there's any reservoir or dam releases. So that's all going to influence the river flooding aspect. Now, if we move into flash flooding and flooding, Rapid rises on small ungauged streams and creeks are driven by slow-moving, heavy rain-producing thunderstorms. We saw several of those types of events happen this last summer. Repeated rainfall over the same area, we saw a lot of that in the summer of 2018. Or if a dam breaks, that's obviously going to cause rapid flash flooding in an area. So these streams and creeks are going to respond in minutes to a few hours of a heavy rain event. And this is a major threat to life and property. Flash flooding is one of the most dangerous and deadliest forms of severe weather. So definitely want to be seeking shelter and getting to higher ground at this point. And these are really important to also report to us. Long duration of moderate rain can also cause to flooding, but at a much slower rate. And if we move on now to aerial flooding, slow rises on small ungauged streams and creeks are mainly driven by slow-moving, prolonged rain events, repeated rainfall over the same area, and then situations where streams and creeks respond after several hours of rain. And these are more of a threat to property than to life because they are a slower moving event. They're not as rapid as, say, a dam breaking and all of that water being rushed into a city. But these are still really important events and definitely something to be thinking about if we have a period of long rain that's happening for a long time and those storms just aren't moving out of the area. All right, so now we'll talk again, a little bit backtracking here to thunderstorm ingredients, and we'll talk a little bit about ingredients and different types of thunderstorms, and then I'm going to pass it off to John again. So first ingredient for a thunderstorm is instability. We need an environment that is conducive to producing thunderstorms. So a couple days ago, or I guess this whole week, if you go outside, you see these cumulus clouds. They're kind of flat. I like to call them cumulus pancakes because they look like pancakes. That is not an environment that is conducive to thunderstorm development. That would be a stable environment. Now, in order to get thunderstorms, we need instability. So we can get this mushroom cloud that's pictured here on the slide. And that's going to allow us to have some really intense and severe thunderstorms. Second ingredient is moisture. If the air is dry, we're not going to get any clouds. So we need moisture in order to get a cloud and then allow that cloud to keep building, keep getting water, keep developing rain, maybe even some hail. And we need a moist environment for that. Third ingredient is lift. We need to get that bubble off the ground. If that bubble is going to create a cloud and then eventually a thunderstorm, it needs to get off the ground. So that can either be done through a front or a mountain, or just simply hot air rising through convection. But we need these three ingredients in order to get a thunderstorm. And most severe thunderstorms are also going to require wind shear. So that wind shear is just basically we have slow moving winds at the surface and fast moving winds aloft. And when that happens, the storms become more severe and will allow more things to happen, like more lightning production, more hail development, heavier rain. If we don't have wind shear, it's not likely that the thunderstorm will become severe. We will still have a thunderstorm, there will still be thunder and lightning and rain, but it might not be severe. So wind shear would be the next ingredient for severe storms. All right, so let's talk a little bit about ordinary thunderstorms and their life cycle. So this would be in an environment with very little wind shear, so we're not going to get severe weather out of this, but we are going to get a thunderstorm. So first, on the left, we start with a towering cumulus. This is that little bubble that's rising to, excuse me, something's happening. All right, we're back. So this is that little bubble that's rising from the ground. It's forming a cloud, and then it's growing and growing and growing. And then we get to the middle picture here, which is mature storm, so maturity. And that's when we have our thunderstorm. It's has an updraft, air is rising, we're getting rain from and we're seeing a downdraft, and water and hail is coming out of it. It's tall, it's reaching 40,000 feet or 12 kilometers, and it looks like nice, bubbly cauliflower thunderstorm. And then finally on the right is dissipation. So little rain is coming out of it. If you can see rain falling, but it's not reaching the ground, we call that virga, and we can see virga in this picture here because we can see rain falling, but it's not hitting the ground. And the thunderstorms died off. There isn't a lot of movement left. There's just kind of a flat cloud at the top. So this is when the thunderstorm has died off and it's at our dissipation stage. All right, and then we get into multi-cell thunderstorms. So this is when we have upper level winds carrying the first cell downstream, and then that's allowing new cells to develop where the previous cell was. So we have our wind moving, wind moving, and it's taking our thunderstorms this like towards the right of the screen, and then we have new towers developing on the left side of the screen here. And that is what we call back building. So when we keep getting storms popping up where the initial storm started, but now the first storm has carried on far away, but we still get this building of the other storms where it was before. So that's called back building. And remember, this is what can lead to flooding or even flash flooding, because if this storm keeps building here and it hasn't moved, we're getting a lot of rain in this one spot that isn't leaving, and that can lead to a lot of flooding concerns. So this is what we look for if we see this kind of pattern happening. And a line of multi-cell thunderstorms is typically called a squall line. This might be a term that you've heard before, a squall line or a bow echo. If they're really, really severe, it can even be called a derecho, which I know everyone's heard because we've had a derecho come through the area earlier this summer. So these are the storms that definitely have the most amount of rain in them, and they contribute to flash flooding. And then finally, if we look at supercell thunderstorms, these are the thunderstorms that are going to produce your really large hail and your tornadoes. So there's a lot of ingredients here and a lot of dynamics to these supercell thunderstorms. It's quite fun. And they're characterized by updrafts that can reach over 100 miles per hour. That's really fast. Imagine air going 100 miles per hour up into the atmosphere and then eventually getting to this overshooting top. That's a sign of a really strong thunderstorm. And these thunderstorms can produce, as I said, strong or even violent tornadoes. So these are the ones that we want to watch out for rotation. By nature, the definition of a supercell thunderstorm is a storm that is rotating. The whole thing is rotating. The supercell thunderstorms can also produce downdrafts that are in excess of 100 miles per hour. So we have an updraft going up at 100 miles per hour, and we can also have a downdraft going down at 100 miles per hour. And you can imagine the amount of damage that that could cause. Those are what we call downbursts or microbursts, and John is going to talk a little bit more about that in just a sec here. And then we have increased risk of tornadic supercells when the winds are turning clockwise with height or veering. Now this is a little bit getting out here into the weeds, but if you're interested, we'll be covering more of the dynamics of these supercell thunderstorms and other storms in the advanced talk. But this is just kind of the scope of the different types of thunderstorms, and now I will pass it over to John.
Thanks a bunch, Rachel. Well, hello everybody. Hope we're hanging in okay. We're turning the corner on the halfway mark, so I think we're still pretty well on pace to be done between 8:30 and 9 or so. So let's go ahead and move forward. Now we're going to talk about sort of where the U.S. spotters come into the picture. We've talked about what storms look like. We hope that's been helpful to understand what you're looking at from the ground to see if it's a single cell, a multi-cell, or a supercell thunderstorm. And now we're going to talk about the types of damaging winds that can occur. Again, we said a severe thunderstorm occurs when winds are 58 miles an hour or greater, okay, with wind gusts. And so let's talk about the different types of winds that exist. Let's see here if I can have my computer respond. Let us see. Ah, yes. Okay, now we're responsive, and now it's probably going to start coming in real quick. So we have straight line winds, we have downburst winds, and we have tornadoes. I'm going to talk about straight line and downburst winds, and then Rachel will be back, and she'll talk to you guys about tornadoes, which is probably a big interest to many of you. But the point with talking to you about this stuff is this is the information that's going to be helpful to us. Okay, so say you're down in Harrisburg, say you're up in Warren County, say you're up in Lycoming County, wherever you might be, having some knowledge about the types of winds that are occurring and the type of damage they produce will be helpful for us to kind of understand, was it a tornado? Was it a straight line wind event? And this is going to help you understand how we do damage surveys as well. So let's go ahead and move forward as we talk about straight line winds. Let's see here. Seems like this thing's being a little bit unresponsive at the moment for some reason. All right, so straight line winds. It might look like this on radar. You can see there's a squall line with a high reflectivity. Severe thunderstorm warning has been issued. This is a line that's coming across, and right also be what we call a shelf cloud with this. Okay, so a shelf cloud is going to precede basically outflow from a thunderstorm. Many of you have seen this. These are a sign of some strong winds behind. A shelf cloud itself does not indicate that there's going to be severe weather, but it can be indication of some strong winds behind it. So this is the most common type of wind damage we see here in Pennsylvania. And again, a squall line generally produces something to this nature. It results from a combination of the forward movement of the storm and transport of high winds aloft down to the surface. So the way that I like to describe this is it's literally like a bulldozer. Okay, so if you think about a bulldozer that's just moving over an area and moving the dirt out of the way, it's very similar with a squall line. Some of these can be right along a cold front as well, where you have the cold, dense air, and fundamentally that's what's happening. You get cold, dense air in the outflow of a thunderstorm, and that seeks to basically undercut all of the air out in front of it and blows everything in a straight line like a bulldozer. Straight line winds may occur ahead of the actual storm at the leading edge of the gust front, so it's also important to note that just because the rain hasn't gotten to you yet, you could still see some severe gusts. A couple of years ago, we were doing on-site weather support down at Creation Fest, a music festival down in Huntington County. And there was a big old squall line coming through. A severe thunderstorm warning was in effect. And the winds preceded the rain by probably about 3 to 5 minutes. And so there were some videos of a bunch of dust swirling around, really strong winds, tents getting blown over before the rain had even started. So don't use dark clouds or rain, I should say. Don't use rain as a guide for when the winds are going to start. Often the rain-cooled air is out ahead of when the rain actually comes. So just be mindful of that from a safety standpoint. So here's a little schematic here. We can start with, say, we have ambient winds at 35 miles per hour at 5,000 feet. So that's a little off the ground. What you can get is as you have rain-cooled air, so rain as it gets produced, or I guess as it evaporates, cools the air around it, creating cool, dense air. That air falls down because it's more dense than the surrounding air, mixing down those winds, downdraft enhanced winds as we'll call them, and the result can be surface wind gusts of 65 miles an hour in this situation. So this is an example of where those winds aloft, when we get really strong winds, often in the spring or in the fall, you can get that mixing down and it can create some wind concerns certainly along the way. Yesterday was a good example of that. It was very windy around here as a cold front was moving through. We had very strong winds aloft, a lot of vertical mixing. And so we're able to mix down some of those strong winds aloft and get them down to the surface, producing gusts, not severe certainly, but wind gusts of 40 to 50 miles an hour in a couple spots across Pennsylvania yesterday. So again, to continue this conversation, the damage they produce is in the single direction, and it's going to be oriented parallel to the direction the storms are coming from. And the thing to note here is it can be a really large area as well. Winds of up to 100 miles an hour or more are possible, and they're often accompanied by many reports of damage throughout the county. I remember I started here in middle of May of 2018, and there was a squall line that went through on my second day at the office, and I believe a severe thunderstorm warning was issued for most of the Commonwealth of Pennsylvania. Very busy day. We kind of know what's coming, but all the trees are all going to fall in the same direction again, like a bulldozer had come through. So now, in fact, I beat myself to the punchline. This was that event. I started May 14th. This was May 15th. You can see there's the squall line coming across. Storm Prediction Center reports here of wind damage. There were a whole bunch across the Commonwealth more as you headed farther south and east. Here's a couple of pictures of the damage with trees completely uprooted. Again, going to be falling parallel to the direction that the winds were moving. Everything in the same line, just like a bulldozer for a straight line wind event such as this. And here's an aerial shot of something like that where all the trees are blowing in the same direction. The unidirectional pattern is indication of a straight line wind event. So if we go out and we see a bunch of trees in the same direction, we're gonna go ahead and say that was a straight line wind event. Straight line winds can be as strong as tornadoes. So just because there's a bunch of damage doesn't mean it's a tornado. But again, it's just about which direction the trees have fallen. Another thing is downburst winds. So this is a schematic here where you have rain-cooled air, an area of dense rain-cooled air that will fall down and then spread out in all directions, kind of like you're dumping a bucket of water onto the ground and it hits and then it expands in all directions. You can see as it moves through, it's similar to straight line winds, but just a little bit different, and it's different in the following ways. Downburst damage driven by the outrush of air from aloft brought down by the thunderstorm, not on the movement of the storm itself. So a storm is moving in a direction and the winds are pushing out ahead of it, again, acting like a bulldozer. In the case of downburst winds, they're going to diverge. Okay, so it's not just going to all go in the same direction, but it's going to fan out in all directions. And so you can even have a downburst that if the storm is moving slowly, say from west to east, you could even have some trees that are blown down to the west because this drops and fans out in all directions. So it's not uncommon to see a pattern like this, where you have some trees that are kind of fanning out as that downburst came through. Downburst can also be referred to as macro or microburst based on the size that they cover. And again, this is where we're talking about. Downburst is a generic term for a specific type of wind damage. But a microburst, it covers an area of less than 2.5 miles or less. So 2.5 miles or less area is a microburst, and then anything bigger than that is a macroburst. Semantics, you probably heard that before though. The thing to note here too, downbursts can be a little bit more intense than straight line wind events on occasion. It's usually a concentrated area of damage. It's not quite as widespread as a squall line, but there might be a pocket of damage. These are really common in the summertime when you get a pop-up thunderstorm. You've got a whole bunch of popcorn convection, as we call it. Maybe a storm will go up, its downburst or downdraft will kind of come down and then spread out in all directions. You're going to have isolated pockets of wind damage caused by micro or macro bursts, very commonly during the summer. All right, it's 8 o'clock right now. We're going to go ahead and take another break here for a few minutes. But what I'd like to do, now that we've talked through winter weather and we've talked about at least the first part of severe weather, or majority of severe weather, except for tornadoes, let's see if we have any questions. Does anybody have any questions that they'd like to ask? If you can go ahead and unmute yourself and ask those, or ask them the questions, and Rachel can moderate any questions we may have. Well, hearing none and seeing none, I guess we'll go ahead and take a break. Let's plan on being back at 8:05, so it's not going to be quite a 5-minute break, but then we'll get started with talking about tornadoes here in a second. Rachel will take back over. If you do have any questions, feel free to put them in the question box and go to webinar, and we'll get to those at some point. Thanks a bunch, everybody. See you at 8:05.
All right, it is 8:05, so we're going to get back to it. And now we're going to talk about tornadoes. So we're almost through. Tornadoes is the last topic before we talk about how to register to be a spotter and all the last final wrap-up thoughts. So just bear with us. We're almost there. Hopefully this is pretty exciting for you. It's exciting for me. I know it's exciting for John. So here we go. We're going to dive into tornadoes. Give me just 1 second. All right. So tornadoes is a very specialized wind event. John just finished talking about all the different types of wind events we can get from different types of thunderstorms, but now we can also get tornadoes, which is just a very specialized type of wind event. And it takes very unique conditions aloft in the storm and at the ground to produce a tornado. Believe it or not, it's not very easy to produce a tornado. A lot of things have to fall into place exactly in order to get a tornado to form. And about 1 in 10,000 thunderstorms produce a tornado. That's a surprising number to me, that it's just so hard to create a tornado. There's active research going on right now about how we even produce tornadoes and what are the key ingredients and the dynamics behind all that. So it's not easy to get a tornado. And Pennsylvania on average sees about 15 tornadoes per year. And the tornado is usually defined or usually produces a very small and defined area of damage, which we call the tornado path. Now remember, the degree of damage does not actually indicate whether or not there was a tornado. There are a lot of other things that we need to think about in order to see if there was a tornado. So degree of damage does not mean tornado. Remember, we saw that video earlier that showed us a severe thunderstorm that had wind gusts and it destroyed those trees, and we saw those tree branches falling over in the road. That is damage, but that is not a tornado that happened. Those were just really strong wind gusts. So we need to know other information in order to determine if it was a tornado. So April 2019 was actually a record-breaking month for Pennsylvania. We saw a total of 14 tornadoes in April, and the previous was 11 in 1991. And we had 4 EF0 tornadoes, 6 EF1 tornadoes, and 4 EF2. So that's a lot of tornadoes, especially for the month of April. That's just the beginning of the severe weather season, so that was quite impressive. Now, if we move on to looking at tornado on Doppler radar, I know a lot of you like to use radar in order to see what's going on, and if you're out there storm spotting, you like to use radar to see what's around you and what's happening. So on the left, we have reflectivity, and on the right, we have velocity. Reflectivity is telling us how much and of what size the particles are that the radar is seeing. Velocity is telling us where are those particles going and how fast are they going to wherever they're going. So it might surprise you that radar can see things other than rain. It can see bugs, it can see it can see trees, it can see buildings, it can see mountains. Radar can see a lot of different things. In this scenario, we're actually seeing a radar pickup on a tornado. So if we look at the right image here in the velocity, we see what we call a couplet, and that's when we have really bright reds touching greens, and that means that we have rotation. In this instance, the rotation happens to be counterclockwise. The radar happens to be off down and to the left, and that is very important for knowing the direction of the velocity and knowing how the storm is rotating. If this radar were, say, positioned in a different location, then maybe this couplet wouldn't be rotating counterclockwise. So whenever we're looking at rotation, reds touching greens, we have to be conscious of where the radar is located in order to know how the storm is actually rotating. So tornado winds are actually much different than straight line and downburst winds, as you can probably imagine. And the patterns of damage show signs of convergence, with winds being pulled into the center of the tornado. So that's what we're going to be looking at when we look at the damage that a tornado may have caused. All right, and yeah, so we see this graphic here showing that we have counterclockwise rotation in this particular image. So now let's talk about the tornado debris signature. You might have heard of this. It's really fun. And it's really fun to look at radar, but we also know that this is when we actually have damage. So first, we want to identify a valid velocity circulation. So we can see here we have our reds touching our greens. Our radar is located down and to the right, so we know that this is rotating counterclockwise. We have really strong rotation here. Then we move on to the correlation coefficient. So you don't have to memorize all of these terms right now, but the correlation coefficient will tell us if there's a diversity of particles with what the radar is seeing. And here we see really, really low correlation, less than 0.85. And this is co-located with the velocity couplet. And this tells us that we have a diversity of particles. So maybe now we're starting to think, okay, that could be some debris. And then we look at the reflectivity image, and we see that there is reflectivity and a hook type shape co-located with the low correlation and with the velocity. So that is telling us, okay, we definitely probably have a tornado here and a tornado debris signature. Then we look at lowering differential reflectivity, or ZDR, near 0. Now again, if you're interested in learning more about the dynamics and about radar, we encourage you to go to the recording of our advanced SKYWARN talk that was held back in June. And if you go to weather.gov/ctp/SKYWARN, you can find links to that and links to other videos and recordings and other handouts and other material that you might like to see. We'll mention this again at the end. I'll probably put it in the chat box for y'all to see. But just know you don't have to feel overwhelmed by looking at the radar now. Just thought we'd share it for you if you are interested in that. So radar, again, is a really interesting tool to look at all these different things. But seeing this, we know that this is a very dangerous situation. We can see that there is debris being collected. So this is dangerous. We want to make sure that if we are seeing this, we are taking cover and we are taking safety precautions, and that we know that this is a very dangerous situation. We don't want to be near this. All right, so now we have another tornadic debris signature actually seen from our own radar here in State College. The radar is located in Center County, and this picked up on a tornadic debris signature on October 2nd, 2018. Excuse me. And it's not as clear, excuse me, it's not as clear as the previous image, but we can still see we have our velocity couplet, we have our reds touching greens. Our radar is located at the bottom left corner, so we know that this is rotating counterclockwise. We can kind of see a lowering in correlation here. It's a little bit hard to see. You might have to squint a little bit in order to see that. And then we also have a little bit of lowering in ZDR. So again, it's kind of hard to see, but we can definitely see that there is rotation and a lowering correlation, lowering ZDR. So this is tornadic debris signature. All right, so now we're just going to move into some terms for understanding tornadoes and understanding how they develop. So the first thing in order to get a tornado is we need a wall cloud. Now this is a rotating lowering that's often rain-free, there's no rain coming out of it, under the thunderstorm. And rotation is the key. If you're looking at a thunderstorm and you have to ask yourself if it's rotating, it's not rotating. You will know. You will know 100% if you're looking at a thunderstorm and it is rotating, because you will see it. You will see the rotation. It's quite fast. It's quite amazing to see. And it's a sign that conditions are right for producing a tornado. Now, while having a rotating wall cloud is good to produce a tornado, we still need to know what the conditions are below that wall cloud to be able to know if a tornado can actually form. If the conditions underneath that wall cloud just aren't right in order to produce a tornado, then we're not going to get a tornado. So a wall cloud, while it's really impressive to look at, it's rotating and it looks scary, and it is scary because it means that we could have a tornado. It's not producing damage. It's not causing any damage, and it's not a tornado yet. All right, and this one happens to be rotating counterclockwise. Most wall clouds will rotate counterclockwise. Excuse me. All right, next we get a funnel cloud. If our wall cloud is successful and it is ambitious enough to produce a tornado, the conditions are right, we will get a funnel cloud, which is a fast spinning funnel descending from the thunderstorm or your wall cloud, but it's not yet touching the ground. Rotation again is the key. You will know if it's rotating. You will not have to second guess yourself. This definitely, even though we can't see a video of this funnel cloud in this image here, we can tell that it's rotating just based on its characteristics. So this is a sign that conditions within the storm and within this wall cloud are right for producing a tornado. It's just not a tornado yet. We still need to think about what's happening at the ground. So a funnel cloud, while it looks impressive and it's scary and it's obviously a rotating column of air, again, it's not causing damage, but it might produce a tornado soon. So this tornado, again, is rotating counterclockwise. Not all of them will rotate counterclockwise. Some of them can rotate clockwise instead, but this in particular case, it was rotating counterclockwise. All right, and then finally, if the funnel cloud is successful, we will have a tornado, which is a rapidly rotating funnel of air in contact with the ground. Rotation is the key. Again, rotation, rotation, rotation. And it's obvious, very obvious in this photo that it's rotating. It's touching the ground because we can see debris that's from the ground being lofted up. And we want to look for damage. If there's no damage, then there was no tornado. So funnel clouds are still really important for people to report to us. If they see rotation, that's really important. But it's not a tornado if it hasn't touched the ground and if it hasn't produced damage. All right, let's see where we are now. So first, we're going to look at the top left video. This is a video of a house that will soon be hit by a tornado. But the most important thing, at least to me in this video, is that the house starts getting destroyed before the tornado even comes in contact with it. The winds are so strong that the house starts getting shingles ripped off right now, siding, other pieces ripped off before the tornado even hits the house. Now, this is why cracking your windows when a tornado is coming doesn't do anything, because the tornado starts to destroy your house before it even gets there because the winds are so strong. So never crack your windows when the tornado is coming. That's just going to allow more debris to come into your house, and you definitely don't want that. This other video is now, we're looking inside an office building and a tornado is about to hit this office building. So it's just showing you the power that tornadoes can have. They're really, really high impact events. They're obviously extremely dangerous. And it's amazing that we even have this footage from this office building to be able to share. So we can see wind outside is picking up, and then all of a sudden debris is lofted into the building. We see some wind circulation in the building. Now the lights go out, all that debris is being carried away, and then eventually the video stops because there's just no more feed. But we can see here that tornadoes are really powerful and definitely nothing to mess with. We definitely don't encourage storm chasing by being a SKYWARN spotter. We just encourage you to spot and report, but not to storm chase. It's too dangerous. All right, so now let's look at some tornado damage. So this is an aerial photograph, and it has what we call a tornado fingerprint. So the red dashed line is our tornado path, and the damage is showing a clear crisscross pattern. So the trees are kind of crisscrossy. We saw before that downbursts, trees diverge away, right? But now we're looking at crisscross trees, which is showing us tornado damage. Now, if we move on, tornado can also have different, tornado damage can also look at it differently for different tornadoes. So another tornado fingerprint is a convergent pattern. So if we look at the image on the right, we see those white arrows are kind of showing us a convergent pattern, and that's when all the wind is funneling into the tornado is sucking everything up, and it's causing there to be damage in a convergent pattern. Image on the bottom left is another tornado fingerprint showing clear cyclonic turning. So we talked about how tornadoes move cyclonically or counterclockwise, and that's shown in the corn here on the picture on the bottom left. All right, and then if we look at some tornado damage from October 2nd, 2018, we see that the trees are splayed out in kind of a crisscross pattern. We can see the tornado path in the grass here. If you squint really hard and focus your eyes, you can actually see some tornado damage in the path. And lots of these trees are actually damaged from inflow of the tornado. So the tornado was so strong it was sucking those trees in, and that's why they're downed. And then the tornado crossed the field and then went on to destroy the forest over here beyond the field. So this is clear sign of a tornado. And when we're looking at damage, trying to determine if it was a tornado or downburst, we will look at the pattern of the trees, which way they fell. And if there's other striking features like the path that we can see here in the field, that is definitely a clear sign that there was a tornado, small circulation at the ground. All right, and then finally, we're just gonna finish here with this tornado video, just showing you the sheer impressiveness of tornadoes. It's quite amazing what they can do. Tornadoes can actually have multiple circulations within them, not just one. You can have upwards of 4 or more, which is really impressive. And they can just cause extensive damage. Thankfully, in Pennsylvania, we don't have the most strong and violent tornadoes, but it is not impossible to have really strong and violent tornadoes here. So definitely in the spring and summer seasons, you want to be looking out if there's a severe thunderstorm warning issued, and if there's ever a tornado warning issued, definitely be conscious of that. Take shelter, seek the lowest part of your building or the interior part of your building if you don't have a basement. All right, we don't have to watch the whole thing. So I guess now we shall move on, and John is going to take over and talk about spotter registration.
All right, I'm back. So this is the part of the discussion where we do the old gotcha. Okay, so if we go back here and we look at this video again, we're going to be able to see that this thing's not actually rotating. Looks like a tornado from a distance. You're like, yeah, this is totally a thing. But part of the fun of that was, wait, did you catch the fact that it's not rotating? Remember, Rachel said it was going to be really clear when a storm was rotating and when it wasn't. This one's not rotating. This is called scud. And so after all that, the point was, are you paying attention? Are you aware? The most important thing is that this stuff is rotating. So make sure that you're communicating that with us. And again, the most important part, if we just saw this still image, you'd be like, oh, that looks really bad. But if it's not rotating, it's not producing damage. So this was just some scud. Fun little activity there to do the old gotcha, and hopefully you pass the test as a part of the spotter training. So let's talk spotter registration now. This is the part where I'd really love for you to zone in here. This is probably the most important part of getting you registered, getting you in our system, and talking about what kind of stuff we're looking for. So if you guys just be with us for maybe 10 or 15 minutes more, we'll roll through these. So let's first talk about what a spotter is. Okay, so what is your role as a spotter? It's to observe the weather. Right, you're the ground truth, the eyes on the ground for us, letting us know what's happening at your location. A spotter communicates, so you're going to communicate information to the National Weather Service so that we can ingest that information into our forecasts and also communicate that information to the public. The spotter also stays safe. Rachel mentioned it earlier with that one video of the tree that was falling over. The point is not to injure yourselves. That would be so dumb. The desire here is that you would safely report the weather to us. The spotter also is a critical role in helping the National Weather Service and local officials. We can't emphasize this enough. It's vital that we have you. When we're sitting in State College, we have resources that help us have an idea of what's happening, but what happens on the ground, especially when it comes to tornadoes, when it comes to hail, when it comes to wind speed, it's a little difficult for us to get the specifics. And so we need that information from you. Now, let's talk about what a spotter isn't. This is really important. A spotter's not a weather expert, okay? We understand there's a lot of passionate folks. Our weather spotters are some of the most passionate people that we know. And we appreciate so much your desire to be a part of the forecasting process and to kind of give guidance. What we're asking is that as you communicate with us, that you tell us what you're seeing, okay? We, as meteorologists, have trained, we've gotten degrees, we spent a lot of time training on this stuff, and so we are the ones that ultimately are responsible for making the decisions. And so, again, we just ask that you communicate that with us. You might have a ton of weather knowledge, we appreciate that, but as a spotter, you are communicating information to us, the weather experts, to take the information you have and to move forward from that. So, again, we just ask that you would communicate the weather to us. If you have an idea, maybe what's happening, let us know. But we're not always going to take that into full consideration or adopt that. based on the myriad of resources that we're using and looking at. Weather spotter also isn't a storm chaser, okay? So the goal here is not to just be chasing storms and getting crazy cool pictures. The goal of a spotter is to, again, actionable, relevant information can come from the National Weather Service based off of spotter reports. A lot of spotters are, or a lot of storm chasers are spotters, and we love that, but it's not just a storm chaser. Another thing to note here, spotter's not above the law, guys, okay? Just because you're chasing a storm doesn't give you the ability or the free pass to speed, to not obey traffic laws and stop signs. And unfortunately, it seems like every year there's some sort of incident, especially out in the plains, with spotters that are just not, or really storm chasers that are not abiding by traffic laws. We just ask, be smart out there. We do want the information that you can provide for us, but let's not do it in a way that would put other people's lives in jeopardy. The other thing is, spotter's not immune to the laws of physics, all right? Getting close to a tornado is not a good idea. It's not like just because you're a spotter, you're not gonna be still sucked up in the tornado. It's not like just because you're a spotter standing under a tree, you're not gonna have the tree fall on top of you. So just be smart out there. That's all we ask. We don't want to have a case where somebody gets killed by a storm just because they're trying to get a good shot or trying to get a good measurement. Do it safely. We'll take whatever information we can get. Your life is way more important than the weather information that you're providing to us. All right, so now what to report? This is pretty simple. Really like this graphic here. First, we want the time. When did it occur? That's important to it so we can match it up with radar. We want the location. Where did it occur? If you're unsure exactly where, give us a nearby intersection or a landmark. We'll figure it out. Generally speaking, in Pennsylvania, there's going to be 1 or 2 storms that are doing a big thing. So you can tell us the county you're in. You can tell us the town you're near. We're going to have a pretty good idea, but if you could just do the best you can with the location, that's helpful. We want the condition as well. What are you reporting? Are you reporting 1-inch hail? Are you reporting heavy rainfall? Are you reporting lightning? Lightning, again, lightning is not going to give us any information that we necessarily need to issue a warning, but we want to know what you're reporting to us. And the source, who are you? We want to know who you are. If you tell us you're a trained spotter, which you are going to be after attending this training, that's going to be helpful for us. Tell us you're a trained spotter so we can take that information into account. So here's an example. I would call up and I would say, hi, this is John. I'm one of your spotters. There's the source. My name is John. I'm one of your spotters. I'm calling to report hail. That's the condition. I'm located in Lancaster City. That's the location. And we've got at least quarter-size hail falling. That's the condition again, right now. Right now is helpful. We want that information as quickly as possible. And at least quarter-size hail, maybe larger, that condition again. So you can see spelled out very clearly, time, location, condition, and source. We may even ask you some more information about it, but those are all very useful aspects. So reporting tips, late reports are okay. We still like those. We still need those. That's part of our verification. It can also help us with storms downstream after they pass through your area. Tell us what happened so we can warn people downstream. We also really appreciate pictures and videos, especially when it comes to snowfall measurements or hail. Pictures are helpful, okay? Because let's be honest, some people can incorrectly estimate the size of hail. It's hard to do that. It's hard to estimate wind speed. It's hard sometimes to figure out how much snow is on the ground. If you have a ruler next to your hail, if you have a quarter sitting next to hail. One thing to note, and Rachel might have mentioned this earlier, if you're sending us hail, if you put it in your hand and take a picture of your hand, that's not helpful. We don't know if that's a baby's hand. We don't know if that's an adult's hand. We can't really gauge that well. So if you could put hail or snow with a ruler in it so we can gauge that, that would be super helpful to help validate the report. And again, please remember to tell us where you are, even if it's just a highway and a city reference. That's going to be really helpful for us as we seek to validate the report and then communicate it out as necessary. So somebody calls up and says, yo, it's getting dark here. Looks like it might be a tornado. It's not helpful. That doesn't really tell us much information whatsoever. So again, we just ask that you communicate time, location, condition, and source. So as far as storm reports for the National Weather Service, so snow here, we like snowfall during the storm to the nearest 1/10 of an inch. When snowfall reports reach thresholds, okay? So the storm total report as soon as the storm ends. But then snow depth, again, as Rachel talked about, that's just gonna be the total amount on the ground. So maybe we've had snow multiple times over the past week. Snow depth is helpful. How much is left there? And then snowfall rates as well. If 1 inch or more per hour, that's pretty heavy snow, or visibility restrictions less than 1/4 of a mile. All that information for snow is helpful. Sleet, we want to hear about it anytime it happens. Those are helpful for precipitation transitions, because often in Pennsylvania, as you may realize, usually the rain snow line somewhere in Pennsylvania. So if we can have a pretty good idea what's happening on the ground, that's helpful. One other thing I'm going to mention as a plug is MPing, M-P-I-N-G. There's an app that you can go to, and it'll get your location. You can report the type of precipitation that's falling. That's also helpful, especially during precipitation transitions in the wintertime. Report to MPing the precipitation that's falling, and we can actually access that data at the Weather Service. That's helpful too. And then freezing rain, as Rachel talked about, any occurrence we want to hear about, and then measuring on branches. We divide by 2 if you're measuring it on a branch. Again, there's the snowfall reports for the National Weather Service. All righty here. Once again, just a smidgen slow to respond for some reason. Thanks for bearing with us. Yes. And then we need the time, location, condition, and source, just as a reminder that those things are important as you report information to us. Now, for severe weather, we're not going to spend too much time on this. This information is available. We'll talk about shortly. Wind damage, hail, tornadoes, flooding. Rotation is important for tornadoes. Measure your hail with a ruler or common object. Wind damage, again, we want to understand what's happened. You can help us say after a storm's gone through, are they mainly falling in the same direction, or are they crisscross? But don't tell us, hey, a tornado happened, there's a bunch of damage. As Rachel said, that's not necessarily true. Straight line winds can also produce a whole heck of a lot of damage. And then flooding, please be safe with flooding, especially. Don't drive across flooded roadways. Don't walk into flooded roadways either. Water can sweep you away, so just be careful. And again, we want time, location, condition, and source. All right, coming to the end here, folks. So how to report. If you go to your handouts, the spotter reporting guideline sheet, I recommend you print that thing out and go ahead and put these numbers in your phone. Okay, so there's the unlisted number, 800-697-0010. This is unlisted for a reason. Okay, this is designed specifically for spotters. So we ask that you not share this far and wide. We want to reserve this for spotters that can get through to us with potentially life-saving information. There's also the listed number there, 814-231-2408. You can get your forecast and then communicate to us at the National Weather Service as well. And please do follow us on Facebook and Twitter. We put out information there at least 3 times a day, often more, especially during active weather. That's our main source of communication with the public. So please go on there and also tweet at us. You can tweet us pictures. You can post on Facebook in the comments section. We use that stuff pretty heavily, so please do that. Or you can send us an email, ctp.stormreports@noaa.gov. If you have pictures or video to share, please send us an email there. We check that regularly as well. So what's next? I'm going to send you an email tomorrow that's going to have a few things. You're going to basically say, thanks for attending. I'm going to attach the slides, and then there's going to be a registration form. With that registration form, the information that we're going to ask you is, are you a spotter already? We're going to ask for your contact information, and then we're going to ask you to evaluate this course. What did you think about it? Again, this is the first time we've done this new and improved course. Are there things that you'd like to hear more about, etc.? And if you're not a spotter yet, we're going to send out a spotter confirmation letter. So please be patient, because we've got several registrants through this entire process. Now, something else that's new, I'd like you guys to zone in here as well. A note about spotter IDs. I expect this may ruffle some feathers a little bit, but just be patient. We're discontinuing the issuance of spotter IDs, and here's why. We have a spotter database of about 5,000 people right now, and maintaining that database is super time consuming. Okay, and the reality is, when you call with your spotter ID, we're still going to ask you where you are, or we can ask you for your name. And if you already are a spotter and already have a spotter ID, that's fine. We're going to keep that in our database. But from this point forward, we're not going to issue new spotter IDs. Now, some may be frustrated by that. Some may think, why are we doing that? Much of the National Weather Service doesn't do spotter IDs anymore, just because we have other means to do it. Your information is still going to be in our database. We're still going to be able to find you by name. We're still going to be able to validate that you're a storm spotter. Your spotter ID has been a way in the past to do that, but we're not going to issue those anymore. And again, if you already have one, you can keep it. If you don't have one yet, we'll just ask for your name. So if you fill out your information, again, if you have a spotter ID, that's fine. You can still use it. But moving forward, we're going to move away from spotter IDs and just be identifying you by your name, and then your address, your location, things like that. So I hope that's okay with everybody. We do think it's a good decision. and it's going to help enhance our spotter program a little bit more. If you do have any questions, though, feel free to reach out to me. So now coming to the end here, again, look out for an email tomorrow, and we'll send out some information. Please fill that out to us. And what you're going to get in return after you fill that information out, I'll send you a course completion certificate, so you can verify that if you need that for course credit or whatever that may be. One other plug as well, if you are interested in more, if this kind of suited your fancy, you're like, hey, I want to learn more about this, check out the recording of the advanced spotter class that we did back in June. We probably won't do another one until next spring or summer. So go watch that. I think it would be really useful for you. Could probably learn some cool stuff. And Rachel and I both will be more than happy to answer any questions that you have via email. Please also reach out on Facebook or on Twitter. Check out our YouTube channel, and then also visit our website. There's a lot of great information out there. So we'll go ahead and open up to questions now. Thank you so much for coming tonight, and we'd be more than happy to answer any questions you may have.
Unmuting myself would be helpful. There's one question that says, can you report via amateur radio?
That is a great question, and something that I neglected to include, and I apologize for that. So yes, during active weather events, we actually have a couple guys that generally come into our office to relay reports to us, or they have access, they will send us emails and CTP storm reports. Yes, so for the amateur radio operators, shout out to Clearfield County Amateur Radio Club for helping get this set up tonight. Yes, you can report those via amateur radio, and then those will get relayed to our office. So that's a great way. We appreciate our ham radio operators. Super helpful, the work that you guys continue to do for us, and I appreciate the way that's continuing to grow, it feels like, in Pennsylvania. But yes, that information does get relayed as well. Amateur radio is invaluable, especially if things hit the fan and we lose our traditional means of communication.
Awesome. There's one person who asked if we register with this NWS office or your more local NWS office. Either one. If you are not belonging to this particular weather office, we will send your information to the weather office that's more appropriate for you. If you'd prefer to just reach out to them, you can do that too. So either one will work. Someone asked how would you know if you had an ID from before? I'll let John answer this one.
Just say you might, but you're not sure. So the first question on that registration form is going to be, are you a spotter? You could say yes, no, maybe. And then it'll ask for your spotter ID. You can just say, I don't know. And that'll cue me to go look to make sure that we're just updating our spotter database instead of a whole new entry. If you don't know, that's fine. I can communicate that to you if you really want it. But again, we're moving away from them. It's not going to be terribly important. So not a huge deal. The biggest thing is I can know that you might already be in our database and can go look for that to update it as opposed to having duplicate entries.
All right, and the rest of them are just kudos to us for them thanking us for presenting and everything and enjoying the presentation. So really happy you guys liked it. And of course, we're gonna hope that you leave us some feedback, some either comments on improvements or what you liked about the course. And we really appreciate you taking your time on a Thursday evening to learn with us and talk about the weather. And we hope that you can take this knowledge and be able to give us some really awesome storm reports for either winter weather or severe weather.
One other plug, we have a few more spotter talks for the rest of October. So please tell your friends. We really enjoy this. We want to educate more people. So if you enjoyed yourself tonight, get on our Twitter or our Facebook page and share our post, because there's a lot more out there to do. We're going to be doing this several more times through the month of October. Please spread the word. We'd love to reach as many people as possible.
Yep. All right. So I think most of the questions are answered at this point. Everyone's just sending kudos. So yeah, thank you for enjoying this and thank you for attending. And I guess we'll leave this open for another couple minutes and then shut it down. What do you think, John?
Sounds like a plan. Yep, we'll stick around if anybody has any questions, but have a wonderful evening, and thanks so much. Great job, Rachel. Her first basic spotter talk.
Hey.
We'll put up this comedy right here, count 1, 2, 3, 4, and 5. And again, our thoughts are certainly with the folks down on the Gulf Coast dealing with a very serious Hurricane Delta making landfall tomorrow night. But thanks for attending tonight, guys. Really enjoyed it.
Someone asked about how many attendees we had tonight. We had about 54.
As many as 60, I think, was the highest number I saw.
Mm-hmm. Someone asked, can we be spotters for more than one area if we have homes in different areas in PA? Yes, if you are a trained and registered spotter, all we need to know is your location at that point in time. So if you call us or you're emailing us or sending a report in, tell us where that report is coming from so we don't think it's one of your other homes. And someone asked, when is our next webinar? John, when is our next webinar?
Ha. Let me check that out here. I'm gonna have to go to Twitter myself to see. Let's see. Next Thursday, October 15th. There's one at 2 p.m. and one at 7 p.m. One on Saturday, October 17th at 10 a.m. One on the 20th at 6 p.m. and then one on the 26th at 6 p.m. So if you go to our Twitter and Facebook page, you can hop on. And Tom Russell, thank you for the shout out. I'm seeing that you shared this information on your Twitter page. That's awesome. We appreciate the shouts out, as it were.
Someone asked, when is our next advanced course?
As I mentioned, we likely won't do another one until spring, just based on it being pretty heavily focused on severe weather. So encourage you again, www.weather.gov/CTP/SKYWARN. And there's a recording up there. You can also find that on our YouTube channel. Rachel and I and a couple others worked really hard to put that together in the spring. So we'll likely do another one next spring. Would love to have you attend. And if you have any comments or questions or even suggestions for improvement for that advanced spotter course, please let us know that as well. After you take that, you can shoot us an email and we'll incorporate some of that information.
Someone asked, what amateur radio frequency or repeater should hams report on?
I do not actually know the answer to that question. So if you shoot me an email, I can get you in touch with some of the main folks. If there's any other amateur radio operators on here that let me know that information, that'd be great. The repeaters are there, and I believe that the Central Pennsylvania SKYWARN group is pretty much able to reach most counties now in the Commonwealth, but I'm not totally sure which frequency to use there.
Someone asked what will be talked about in the advanced course. That's going to be more thunderstorm dynamics, in-depth, like short-term radar course, or like a crash course, sorry, on radar, learning about really the more in-depth ingredients and what other tools you can use for understanding the weather, doing your own weather forecasts, and being able to understand real-time what is happening. Again, it's pretty thorough. It's like really explained thoroughly in the recording of the advanced talk. So if you don't want to wait till spring, you can just watch what we already did this last spring and get that in there. And that also, if you watch those videos, you can tell us that I watched it, and then you can get certified to be a spotter by telling us that you watched those videos and that you've gone through that. All right, John, you're getting emails sent to you.
Look out. Flood my inbox, I dare you.
All right, looks like questions are kind of slowing down here, so we'll probably shut this off in the next minute or two. Someone says they like our YouTube channel. Thank you. All right, I think we shall wrap it up. It's 8:45, so we're about 15 minutes early. Thank you so much for attending again. We look forward to hearing from you in the future with either emails or from storm reports. So take care, have a great weekend, enjoy your holiday, and enjoy the nice weather.
Take care, everybody.